Hi, welcome to this special edition of Air Force Space Today from Cape Canaveral Air Force Station, Florida.
It's the end of an era for the Defense Support Program. The first wideband global SATCOM satellite takes flight. We take a look back at the event which started the space race. And we transport you into the farthest reaches of space on Air Force Space Today with your host, Krista Knaus.
The Delta IV heavy lift vehicle, the first to carry an operational payload, awaits its historic launch here at Cape Canaveral Air Force Station, Florida. The Delta IV will boost the 23rd and final Defense Support Program satellite into orbit, continuing a legacy of protection dating back to 1970. Air Force Space Today brings you the end of an era.
We are literally standing on the shoulders of giants.
It makes the career that I'm in fulfilling. You know, you get to see a great team of folks building a spacecraft and ultimately knowing that that spacecraft is going to help the young men and women who are out fighting the day-to-day battles around the world.
The teamwork that happens here is the amazing thing.
It's a big milestone for a lot of people.
For a customer-contractor relationship, it is exactly the way it should be.
And they're very selfless individuals here at DSP.
I personally don't think it's going to get any better than this, and I count my lucky stars every day that I'm able to serve with the caliber of people that I serve with.
The whole team has come together. They've been together for 30 plus years. They really are a true family.
To be able to build and bring something, culminate a legacy of success for our nation, it really is overwhelming.
And it's always been exciting to work with this team. They work together. They're a team.
You're going to be really happy, and you know you're going to be really sad when this thing goes, because this team has grown together over the years.
We have a very unique contractor and Air Force relationship, which I truly believe has led to our success. We've got people on this program that have been here for over 30 years. I have inherited a great program, first of all. Those that have come before me, we are literally standing on the shoulders of giants.
The first milestone was getting that satellite here to the Cape. I had the privilege of riding in the C-5 with that satellite with a great team of folks. They did an awesome job that night.
This is a huge milestone. This is DSP-23. This is the 23rd in a long line of DSP satellites to fly. This is the final DSP that will fly on orbit and provide the warfighter for years to come missile warning and missile detection.
The satellite is being kept in the Cape's Large Processing Facility under the care of the 45th Launch Support Squadron.
Tonight the spacecraft's going to start rolling around 12 o'clock. It's going to move over to the launch pad, pad 37, the Delta IV pad. It's about a 3-hour move, very slow move, and it won't be going very far, but it's just a very slow move.
What is your process with your specialty? What is your background and what you...
I'm in charge of all the integration and tests. So basically back at Space Park, we take the raw spacecraft structure and we populate it, we integrate it, and we do all the system tests on it, and we support it all the way through launch. So in a sense, we're cradle to grave.
One of the reasons it's done at night is down here at the Cape, the winds during the day and weather is unpredictable. For some of the lifting and hoisting operations that are going to occur in the early morning time frame, it's better to start moving out there now so that we don't have to battle the winds in the morning. And then tonight just happens to be a beautiful night.
It's sunrise here at the launch pad after a 3-hour transfer of the final DSP satellite. The next phase, the 17,000-pound encapsulated payload stack containing the DSP satellite will be hoisted onto the Delta IV Heavy.
Obviously, we're coming to the end game
for this significant launch. I mean, it's key to get the operational capability up, but it's also key to prove out a very vital component of our launch capability, and that's the ability to launch heavy payloads. So this processing of this Delta IV Heavy with the DSP satellite has proven out a lot of the technical details and the concepts of operations of how we're going to do heavy lift operations in the future.
That's the best part about being down here is you go through all this work, but at the end you get to see that rocket launch and see that satellite go on its way to orbit. So it's very fulfilling.
For lack of a better term, it's like a giant orchestra. All the different agencies involved with the different winds and the brass and coming all together for launch day, it's incredible. To see all these folks, how they mesh.
All right, you're clear to go.
And the communication is top notch.
To get us to where we are today, this is a big deal.
It's just an awesome sight to see, and to see your end product, something that you've been processing for a long time, especially DSP. The nominal flow is about 6 months, but for this one right here, it's extremely special to see your end product go into space and help the warfighter the way it does. Because I have friends on the desert that they praise the early warning capabilities that they have out there, and it's awesome.
An Atlas V launches from Cape Canaveral Air Force Station, Florida, carrying the wideband global SATCOM satellites. The U.S. Air Force launches the first of the next generation of military communications satellites as a United Launch Alliance Atlas V booster carries the first wideband global SATCOM satellite, SV-1, into space. WGS is the nation's next-generation wideband satellite communications system. The launch begins the process of augmenting and eventually replacing the aging Defense Satellite Communications System, which has been the Department of Defense's backbone satellite communications for the last 2 decades. Wideband global SATCOM satellites are a quantum leap forward in communications capability for the warfighter, providing more than 10 times the capacity of its predecessor, Discus 3. A communications satellite built in the 1980s would have about 30 or so communication pathways. The new WGS has over 1.2 million pathways, the Department of Defense's highest capacity communication satellite. A large spacecraft, once fully deployed, its solar wings span an impressive length of 135 feet. These satellites will provide two-way, point-to-point, multicast, and broadcast communications, supporting U.S. troops around the world. This launch campaign is the culmination of a government and industry team effort for the Air Force, which involved the United Launch Alliance, the Boeing Company, the 45th Space Wing, the Aerospace Corporation, and the Launch and Range Systems Wing at the Space and Missile Systems Center, Los Angeles. At present, the Air Force plans to deploy 5 WGS satellites. Once the satellite becomes operational, it will be DoD's highest capacity communication satellite and provide critical information for the U.S. and its allies.
This is Atlas Mission Control at T-minus 10.
This mission
9,
also marks the 11th flight of an Atlas V rocket from Cape Canaveral and extends the string of consecutive successful operational launches to 52 for Air Force Space Command.
Atlas engine ignition, 1, 0, and liftoff of the Atlas V rocket carrying the WGS SV-1 spacecraft for the United States Air Force.
Welcome back to our studios in Los Angeles.
We have liftoff.
A United Launch Alliance Delta II rocket launches the 4th modernized Navstar Global Positioning System Block 2R satellite. This is the first Air Force launch on a Delta II this year, and the 6th overall Delta II launch. GPS is a space-based radio positioning system consisting of a 30-satellite constellation that provides navigation and timing information to military and civilian users worldwide.
Because of the satellites that are up there,
we're all on the same page of music. We can hurry up, get our mission done, and get home.
President Bush has directed increased efforts to improve U.S. space situational awareness. In a memo, the president directs the state and defense departments to form a cohesive government-wide approach, both to avoid future anti-satellite launches and formulate plans on how to deal with them if they should occur. Driving the government's intensified focus on space situational awareness are concerns that China or other adversaries could directly threaten satellites in low Earth orbit or endanger space capabilities by creating additional space debris. Metal trays in the dining hall, open bay barracks, and World War II Jeeps, all memories of an Air Force long gone. Chief Robert Gaylor, former Chief Master Sergeant of the Air Force, has been with the service for 59 years. During his career, he became Chief Master Sergeant of the Air Force, the highest enlisted rank. Although he retired from the service in 1979, Chief Gaylor is still very active, traveling to bases around the world, encouraging the young airmen of today with the wisdom of yesterday. In a recent visit to Los Angeles Air Force Base, Chief Gaylor sat down with the Air Force Space Today team to talk about the state of today's Air Force and the progress made since the brown shoe days, as well as the experience as the Air Force's senior enlisted man.
It was challenging, it was exciting, it was frustrating, it was tiring, it was every emotion and feeling you could possibly think of.
Chief Gaylor joined the Air Force back in 1948, when the service was only a year old.
I've been around the Air Force 59 years. This is my 31st base this year, so I am in tune with today's force. What I'm seeing in my travels is a willingness to accomplish the assigned missions with minimal complaining and griping about it. And they are just marvelous, really. They are disciplined, they are willing to learn, they are performance-oriented. I'm just very impressed. Technology are things, they're gadgets, they're pieces of equipment that for the most part are dormant until somebody activates them. So people are the most important, but you know what, really, I'd prefer to bring them together.
Chief Gaylor says the key to a successful career today is the same as it was when he was an airman. It's all about attitude.
I'm a living example of that. I was never the brightest guy. I was never Mr. Brilliant. I was never the guy that always received the plaudits, but I always had a great attitude. I always did my job. I always was a good team player. I went to work intending to work. When I played hard. Played a lot of baseball. I recall the day when females made up less than 1% of the enlisted force. 19.6 is what we are now. 19.6. I like what I see from the top down. The four-star generals, there's about a dozen of them. They're intelligent, they're caring, they're involved, they're communicators. Then on the responding end, I'm finding the airmen and the enlisted members absolutely ready to respond. And so when you look at the structure of today's force and the response we're getting, you gotta love it. You gotta say we're doing some things right.
The payload equipment module of the Flight 3 Advanced Extremely High Frequency Satellite has been shipped from Lockheed Martin Space Systems in Sunnyvale, California to Northrop Grumman Space Technology in Redondo Beach. The payload equipment module consists of structural panels that provide housing for all spacecraft bus and payload systems, as well as thermal control. Once testing is complete, the payload will be shipped back to Lockheed Martin Space Systems Center for final integration with the Core Propulsion System module. On October 4th, 1957, a scientific and technological event of immense proportion was to shake America's beliefs in its superiority and security to its very core. This occurrence was magnified shortly afterwards with the following radio broadcast.
This is Radio Moscow, and here is the news.
Our satellite Sputnik lifted at 22 hours 28 minutes Moscow time and entered orbit around the Earth.
Moscow shocked the world with the successful launch and deployment of Sputnik 1, the first man-made object to orbit Earth. Sputnik, weighing 183 pounds, was the world's first artificial Earth satellite. On an elliptical path, it took approximately 98 minutes to orbit the planet, launched on an R-7 Soviet ballistic missile before Radio Moscow made the announcement. It was the dawn of the space age, ushering in new political, military, technological, and scientific developments that will continue for the next 50 years and on.
I would say that the successful launch of Sputnik, the first man-made satellite about the Earth, was a big stimulus for aerospace engineering in the country. I think it wasn't even called aerospace then. We called it aeronautical engineering at that time. And that was a shock treatment because we in the United States were used to being the best and the first in everything, if we did say so ourselves. And here, this group of Russians had managed to pull off just a beautiful event, very spectacular, and they were the first.
The deployment of Sputnik changed everything. It was not only a technical achievement, but it jarred America awake from its slumber, a condition brought on by a false belief that our number one adversary in the Cold War, the Soviet Union, was not capable of such a technological and scientific achievement. This translated into the public's fear that the Soviets had the capability to launch ballistic missiles that would carry nuclear weapons to potentially strike U.S. cities.
After the launch of Sputnik, again, it was a wake-up call. It implied a technology of a rocket launch system and guidance that we in the United States had yet to demonstrate. And so with regard to the creation of long-range ballistic missiles and for ultimately for satellites that we now use for communications and guidance and everything, the Air Force played a key role in becoming, I will say, the leader of the military side of space. You had NASA doing, we'll call it the domestic side, but the Air Force jumped right in and started working the problem on several fronts, mostly for defense systems.
The consequences of Sputnik were profound, both in positive and negative ways. It directly led to the creation of NASA and the passage of the National Defense Education Act, and triggered an accelerated pace of applied research with enormous advances in science and technology, which included such things as GPS, photography from space, weather satellites, cell phones, and would launch the most phenomenal adventure in human history.
When Sputnik was launched on October the 4th, 1957, the Air Force's space program consisted of one satellite development program, known as the Advanced Reconnaissance System, or Weapon System 117L, and a handful of minor studies and plans for eventually using ballistic missiles to launch more satellites or space probes. The Army, for example, had a satellite program, and the Naval Research Laboratory had a satellite program called Vanguard. It was supposed to launch the main U.S. contribution to the International Geophysical Year. But the first Vanguard launch in December 1957 failed, and the Army got the go-ahead to launch its satellite, Explorer, which it did on January 31st, 1958, and it became the first U.S. satellite.
Though the Soviets were first to launch a man-made satellite into space, on January 31st, 1958, the United States successfully launched Explorer 1 on a Jupiter C vehicle, a specially modified Redstone ballistic missile and direct descendant of the German V-2 rocket. Explorer had the distinction of providing evidence of a radiation belt around Earth that would later be called the Van Allen Belt. This was the first major scientific discovery of the space age. The rest is history.
In April 1990, Air Force Colonel Loren Shriver was spacecraft commander as the Space Shuttle Discovery took off on its mission to place the Hubble Space Telescope in orbit. It is doubtful that Colonel Shriver or anyone else could have predicted how Hubble's discoveries would transform the way we look at the universe. It was over 3 years before the telescope's full potential was realized. Although it was already delivering much clearer images than any ground-based telescope in history, a servicing mission was required in December 1993 to correct a small imaging flaw in Hubble's primary mirror. Within a month, the pristine images that had been expected were being sent back to Earth. Orbiting at an altitude of over 300 miles, well above the blurring effects of Earth's atmosphere, the Space Telescope has provided unprecedented views of the universe. It has become one of the most important instruments in the history of astronomy. The telescope has beamed down over 700,000 images. It has provided measurements helping scientists establish the size and age of the universe, and offered evidence that the universe is expanding. The telescope has helped change black holes from theory to fact, and shown galaxies in all stages of evolution. And these are but a handful of Hubble's many contributions to astronomy. To keep functioning properly, the telescope requires regular maintenance. It's the only telescope ever designed to be serviced by astronauts. Besides the initial repair mission in 1993, there have been 3 other servicing missions. These missions have not only maintained Hubble's performance, but upgrades have been added to increase its capabilities. One final servicing is scheduled for 2008. Around 2013, Hubble's components will degrade to the point where the telescope will stop working, but a worthy successor is waiting in the wings. The James Webb Infrared Space Telescope is scheduled to launch in 2013. This telescope will study objects from the earliest universe and should provide even clearer pictures from its orbit, 940,000 miles away from Earth. Meet John Higashi, a software support engineer for Northrop Grumman. Air Force Space Today had the opportunity to visit with him on our recent trip to Cape Canaveral. John may be an unassuming man, but he's probably built more satellites than the entire United States Air Force.
Gonna make a DSP model out of Pepsi cans. I've been with DSP 22 years. You know, it all seems like a blur. It doesn't seem like the many years. Been out here for almost 3 years. Should be a 9-month operation. But things like that happen. The first time I made a model was about 10 years ago. I was totally bored. Noticed that a DSP looked like a Pepsi can. Everyone would drink enough soda that we had extra cans, and in Florida, the recycle of aluminum is virtually non-existent. You don't get any money for recycling aluminum, or very little, so doing something else out of it made more sense. Someone has to drink 6 sodas of their choice. Sodas, beers, anything but tin. Although I did have somebody get a Slim Fast. I got lucky with the first time I made one. It worked. I've glued my fingers together more than anything. That's about the only hazard. And that just means you lose a little skin, prying your fingers apart. I'm going to be working over on the orbital side of DSP for a little while, so I'll still be on DSP. I normally would keep it to one color, but in order to make it closer to what the satellite colors they really are, I use the caffeine-free Diet Coke, or caffeine-free, Diet Coke for the gold. For the lower compartment, And for the upper compartment, it's silver, so Diet Pepsi can works fine. And the blue is what, the Pepsi blue is what normally the satellite body looks like, and solar panels. So now it's starting to look like something. Actually, I'm getting close to the end. That's it.
And that'll do it for this special edition of Air Force Space Today. Thanks for stopping by.